Hello guys, again I'm Dr. Andy, and as we talked before, we are going to continue our playlist about the uh, radiological meaning of Radiomics. In the first part, we are going to talk about the first order Radiomics features. As we told, we have a matrix of the value of intensities, and now we are in the first order Radiomics features. We are focusing on this matrix. At the first, we have the energy is the sum of the all values, and the total energy is the same, but it is also talk about the volume each voxel, not only the value of it. And then we are going to talk about the entropy. In the entropy, we are talking about the random. This is a formula that we give the matrix and to the formula, and it return a value more higher value is talk about the more random in the value, and it is also related to the image, also diagram images. And then we have the minimum, the smallest values in the this matrix, and we have a 10th percentile is statistical meaning. The value that 90% of the values are higher than it, and the 9th percentile is the value that only 10% values are higher than value in our matrix, and it is maximum again highest value. Mean the mean of all the values, median is value that half of the values are higher than it and half of the values are lower, about the number of values. And we have interquartile range. If say the 25 percentile and 75 percentile, it is the values that they are between these percentiles. 25 percentile is about 75% of the values are higher than it, and the 75 percentile is on only 25 percent of the values are higher than it. And after that, we are talking about the range is the difference of the max and minimum. And then we have another feature, mean absolute deviation. And mean absolute deviation is the mean distance of all intensity values from the mean value. We have absolute, and we are the minus of each value difference from the mean, and it is has a absolute. So all of them are positive. After that, we have a robust mean absolute deviation. Robust mean absolute deviation is the mean distance of all intensity values from the mean value calculated of the subset of image array with their level. It is talking about all intensities, but it is talking about the intensities that are between 10th percentile and 19th percentile. We have omitted the extreme values, extreme low and extreme high value. After that, we have a root mean squared. Root mean squared is the square root of the mean of all the squared intensity. We don't talk about only the exact intensity. We are talking about the square root of all the intensities. So all of them are positive. This is another measure of the magnitude of the image value. And always larger value. And then we have a standard deviation. Standard deviation is the statistical formula. We use it on the image intensities. And then we have two important features: skewness and kurtosis. We have a distribution of intensities of our dicom intensive matrix, and we are going to talk about these sum diagrams. First of all, about the skewness. We see it here. It is if our distribution is in a way that the mean is has a higher value than the median, we have a positive skew. If mean and median are equal, we have a symmetrical distribution, and also if our mean is less than our median, we have a negative skew. And about the kurtosis, you can see it here. If we compare to the normal distribution, is if the highest peak is higher, it means the more values are distributed around the median. So we have a positive kurtosis, and if it is less than, they are not. Most of the values are around the median. It is more likely to be flat, so we have a negative kurtosis. This is compared to the normal distribution. And also we have a variance. That's a statistical value. We use the formula of variance for the intensity matrix. And uniformity, it is totally different. It's the formula that say how less the randomness, how predictable the values in the matrix. It is the end of the first order Radiomics features. Thank you for your attention. Have a good time.